we're going to start learning how to draw what are called Lewis dot diagrams or Lewis structures. These are just diagrams that help us represent valence electrons and then what those valence electrons are doing. So again, Lewis dot diagrams, sometimes known as electron dot diagrams or structures. And these are just diagramming the bonding between atoms or ions. It also shows us lone pairs of electrons as well. The dots on our Lewis dot diagrams are representing valence electrons. So valence electrons are the electrons that are involved in all of our chemical bonding. So those are the only electrons we really need to depict. We do not depict our inner shell or our core electrons when drawing Lewis dot diagrams. I'll refer to these as LDDs in the future, just simply for ease of writing. So the first thing we'll do is we'll just draw the Lewis dot diagrams for our atoms, and we'll go across period 3. And if we remember sodium, or if we look at sodium, sodium is in family 1. So sodium has 1 valence electron, and typically there is a pattern to how we draw them. So the first valence electron will go above sodium, upper left at the top of sodium. Magnesium has 2 valence electrons because it is in family 2. So I would draw the first one up here and then the second one over on the right side. For aluminum, it has 3 valence electrons, so 1 on top, 1 to the right, and then 1 on the bottom. Then we've got silicon, which has 4 valence electrons. It's underneath carbon. So carbon and silicon both have 4 valence electrons, so that's going to be 1, 2, 3. The fourth one is going to go over here on the left side. And then we'll start doubling up. So phosphorus and the family that phosphorus is in tends to have 5 valence electrons. So it'll be 1, 2, 3, 4, 5. Sulfur has 6, or its family has 6. So it's going to be 1, 2, 3, 4, 5, 6. Chlorine and the halogen family have 7. So 1, 2, 3, 4, 5, 6, 7. That's starting to get sloppy, sorry. And then argon is a noble gas. So your noble gases generally have 8 valence electrons. So it'll be 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. So again, our dots represent our valence electrons. We do draw them in these pairs. Maybe that wasn't the best picture, so I'll draw it a little bit neater. So we will draw them in these pairs. Don't draw them in like a random circle around. It just gets a little bit confusing. So now we're also going to draw our Lewis dot diagrams for ions, because the first type of Lewis dot diagram we're going to learn how to draw is for ionic compounds. So sodium had 1 valence electron. It's going to lose that valence electron, so that valence electron is going to disappear. We know that the undershell has 8, but we're not going to draw those. What we're going to do instead is, sorry, I keep drawing all these random lines, is that we're just going to say it now has a positive charge. So no dots, positive charge. Magnesium had 2 valence electrons, but it's going to give both of those away. That's going to give it a 2 plus charge. Aluminum had 3 valence electrons. It's going to give away all 3 valence electrons, and that's going to give it a 3 plus charge. So the Lewis dot diagram for your cations is basically no dots and their charge. Silicon doesn't typically form an ion, so I'm just going to skip. Phosphorus's family, they had, remember, those 5 valence electrons. So what it's going to do is it's going to pick up 3 more valence electrons. You don't have to draw yours in a different color. I'm just doing it to make the notes a little bit more clear. So now it has all 8 valence electrons. We're going to put them in brackets so that we show that they all belong to phosphorus and we don't accidentally show that they belong to somebody else, and that this now has a 3- charge. So your anions are going to have all of the dots, basically. So same thing's going to happen with sulfur, except for sulfur had 6 valence electrons to start. So sulfur, when it forms an ion, is going to take 2 more electrons. So now it has a full shell. So all of these belong to sulfur. They don't accidentally belong to phosphorus or chlorine. And this happens when sulfur has a 2- charge. Chlorine, 7 valence electrons. And it's going to gain 1 more. And when that happens, again, all of these belong to chlorine. They aren't accidentally argons. That's going to be a 1- charge. So the difference between your cations is that your cations will have no dots because they gave all their dots away. And then you're going to write their charge. For your anions, for your nonmetals, what's going to happen is that they're going to have all their dots, which means 8, except for, again, helium, that's the exception. So all the valence dots, and then you're going to write the charge. Oh, and then don't forget your brackets. And brackets. Okay, so that's how we write our ions. So this is going to be really important because our Lewis dot diagram for our ionic compounds is just basically writing these Lewis dot structures together. So I'm going to do 2 examples for you, and then you're going to practice these ones in this chart for class. So I'm going to do sodium and chloride, and then I'll do calcium and fluoride. So sodium and chloride, as sodium. First, the thing I'm going to do is I'm going to write down the chemical formula for the compound. So sodium is a 1+ charge, and chlorine is a 1- charge. So I only need 1 of each of them. Remember, plus charge. If you want, you can use that swapping trick to figure out the formulas. But you do have to write the formula correctly first. So it's going to be 1 sodium and 1 chloride. So I'm going to rewrite that with less things. I'm going to write the formula as NaCl. Now that I know what the formula is, it'll make it easier for me to write their Lewis dot structure. The first thing I'll do is write the Lewis dot structure for sodium. I can see up here that it's no dots and a plus sign, and I have only 1 of them. So I'm going to write Na and then the plus sign, because that is the Lewis dot diagram for a sodium. And then I'm going to draw the Lewis dot structure for chlorine. So I'm going to look over here, and I can see that it's all of the dots, and now it has a minus charge. Don't forget the brackets. So it's going to be Cl, all the dots, all 8 dots, because remember, it has a full valence shell now, and it's negatively charged. So this is the Lewis dot diagram for sodium chloride. If you're really imaginative about what's happening here, remember sodium had a dot. I'll draw the chlorine in a different color. Chlorine had 7 dots. And what ended up happening is that sodium gave its dot, its valence electron, to chlorine. So now that means that sodium has no dots, and chlorine has taken that dot and now has a negative charge. Right? So it gives us an idea of what has happened to our valence electrons. All right, I'm going to do another one. It's a little bit different, so it'll be a good one to pay attention to. I'm going to erase some of this stuff. I'm going to do calcium and fluoride, which is going to be a little bit more complicated because calcium has a 2+ charge and fluorine has a 1- charge. So if calcium has a 2+ charge and fluorine has a 1- charge, what's actually going to happen is that calcium is going to attract 2 fluorines or fluorides to get to net neutral. So the formula is actually going to be CaF2, right? So 1 calcium and 2 fluorides. Another way to look at this, if you want, is to think about the fact that calcium had 2 valence electrons. And then remember, our fluorides each have 7. So here are my fluorides. And then what ends up happening is calcium gives up 1 electron to this fluoride, because that fluoride really wants 1. It's got 1 more valence electron to give up. So it's going to give it up to a second fluoride. When that happens, you're going to end up with calcium that has a 2+ charge. The dots are gone. And you're going to end up with fluoride, but you're 2 of them. This is where it's tricky, right? Because this one over here, you only had 1 of each. So what we're going to say is we have 2 fluorides that now have full valence shells, and they have a 1- charge. So we're going to throw that 2 in there to represent that 2 subscript. So that tells us that we have 2 of these. If I had multiple calcium, if I had 2 calcium, I would put a 2 out here. So that would be 2 calcium, 2 fluoride. So we don't use the subscripts anymore. The subscripts basically turn into these coefficient numbers. But then I still draw my ion Lewis dot diagrams like I was before. So that's another way to sort of look at it. So you're going to do a couple more practice down here. I do recommend coming up with the formula first. So again, looking at their charges. So cesium is a 1+ charge and bromine is a 1- charge. So you want to look at their charges, figure out what the formula is for the compound. You can name them for fun. This will be good naming practice, just sort of to practice that again. For ionic compounds, remember the names are the first element and then the second element with an "ide" at the end. Except for your type 2 metals. For the type 2 metals, remember the charge is always written as the Roman numeral. So remember, this is an iron with a 3+ charge, but that also has to be included in the name. All right, so if there's more questions, let me know during class. Good luck with your practice.